So before we talk about the muon detector, I'm going to tell you guys about muons. So muons are a subatomic particle similar to electrons, but a lot heavier, and we can detect them when cosmic rays interact with the atmosphere in larger particles, and they have a lot faster of a decay rate than electrons do.
We can use this material called scintillation material to turn the kinetic energy of muons into photons, which then we can detect in our photomultipliers.
And so this is the old design to which the photomultipliers would connect to. This would amplify any signal that we would get from the muons, and we used this for testing before, but now it's a lot bigger, so we made it smaller, more efficient, and less components.
Today, this is our current design. As he said, we use a much smaller port that only really worries about power delivery and signal pull. We have 4 of them currently in the corners, but we hope to increase that number so that we can get more concurrency detections. And we use 2 oscilloscopes, which allow us to pull out those signals and display them. Once we display those signals, and eventually we hope to use LED grids to make them more interactive.
We have our LED grid that we soldered strips of LEDs with, and we can put that on the walls and the back of our muon detector here to display the X and Y position of our muon going through our box.
What I've been doing is I helped lay out the setup of LED strips on this board. Then we will take a couple of these boards and place them on the bottom and on the top of the muon detector to show exactly what the muon pass through on both the top and the bottom. People will be able to stand inside it to see where the muon pass through them. Then we have down here the electronics used for converting the light signal, a voltage signal that we can read using a computer. And then what I helped with partly is I helped testing and troubleshooting some of these electronics for the detection of muons.
When muons are going to fall, we will see plenty of LEDs lighting up because the photons are getting detected. We further connect this to a system of generation of waves, and we see the waves based on the amplitude of the waves. We recognize how much actual energy is being produced by these photons that is getting converted from a muon. So based on that amplitude of energy, we can position where they're actually falling on the big surface. So that kind of helps us locating the actual position of falling of the muon, which is also known as the triangulation principle. I actually help with fixing all the electrical equipments on the detector. So from fixing little capacitors, which were about 1 microfarad, and soldering those in, and then fixing the main parts. It was really tedious to look closely into those little equipments and making sure that all the ports are matched to the guide that we received to actually make the muon detector. So matching all those little numbers and then matching the equipment pieces to those right places and then soldering those at the correct position was the task that I worked on.